right, when we look at this one, we're still going to use relationships about parallel lines, because you see that you do have lines that are parallel there. But we should be able to go through this problem and find out facts about exterior angles or remote interior angles. We should be able to verify things about linear pairs, verify things about triangle sum. So there's a lot of stuff going on here. Maybe we don't need all of those ideas or concepts to actually find x and y, but I want to show that once we find x and y, that all those relationships still are maintained. Every rule that we come across in geometry or mathematics in general should never contradict something else. Okay? It should never contradict or show false another statement or another rule that we've already defined. So when I look at this, my eyes are drawn to two things: the triangle and the parallel lines. Okay? And hopefully those are the things that you guys recognize here. And I always go to parallel lines first, because there's a lot of information I can gain from parallel lines. What information can you see here from parallel lines? If I look at just those parallel lines and that transversal, what you find Roger, in front of you?
Yeah, x is 110.
Yeah, x is 110. So why is it 110? Correspond. Okay. And I've had people in the past also say, well, maybe I couldn't find x right away. Maybe their eyes go to the fact that that's got to be 70, right? Okay. So because 110 and 70 are same side interior, and then 70 and the x should be linear pair, right? So it gives me 110. So any approach that you want to go through there to get that 110, that's fine. Okay. Now we've got a couple different things we could do. All right. Hopefully we see that when we deal with that angle right there, okay, for the triangle, just look at the triangle. Don't even worry about the parallel lines anymore. If I look at that red angle for the triangle, is that an exterior angle? Okay. So that we should be able to compare that exterior angle to that remote interior and that remote interior there, right? So if that x is 110, 40 plus y has to equal that, right? So what's y got to be? What plus 40 will give me this 110? 70, right? Okay. Now that's nice. That's one way of doing it. Some people might have not done it that way. Some people might have said, well, if this is 110, this red exterior angle here, make it blue now, if that's 110, we also know that that's 70, right? Because they're a linear pair. A value that's 70 they weren't asking us to find, but we know it to be true. And we know it to be true because it's a linear pair, but don't we also know it to be true because it's vertical to that one? So you're starting to see a lot of relationships about linear pairs, about vertical angles, about exterior angles, remote interior. And then there's another one. What should those three angles add up to there in that triangle? 180. And regardless of the approach that I took, when I find all three of them, do I get 180? Yeah. Okay. So when you ask questions like, how do I do this problem? There are so many different ways. Okay. But the more you understand your relationships and that come from your postulates and your theorems and that kind of stuff, the maybe easier it is to kind of progress through a problem like that one. If we go to something like 14. It's the same idea, but you got a lot of triangles here. I think fourth period yesterday we actually got to this one. We started counting how many triangles are there, and there's actually like 8 triangles. Okay? At least 8 triangles. Okay? So we got a lot of relations, but you can also see that there's supplementary angles there. There's a bunch of linear pairs. A lot of linear pairs here in this region here. Okay, you got linear pairs down here. So you're going to see the link between a lot of linear pairs, a lot of vertical angles, and then the fact that we've got also triangles here, so we should have the 180 idea with triangles. It doesn't tell you where to start. That's what maybe some people struggle with problems like this, is where to start. Just pick somewhere and start moving things around and trying to figure something out. Okay, maybe I start with this 65 here. Okay, and I start looking. Maybe I look at the first shape that I draw my attention to that has 65 in it, right? And that's a quadrilateral, correct? We don't know anything about quadrilaterals yet, right? It's probably not a good thing to start with. So then I say, okay, well, 65 is also part of that triangle there, correct? Okay. So if that's 65, do you know what this angle here is?
Yes.
90. So now in that triangle, you have eaten up 155 degrees, correct? So what do you have left over for this angle up here? 25. Okay? So we find out that y ends up being 25. All right? Not the only way we could have done that. Let's go through it. Now I know we still want to find x in that other triangle, but once I find y that way, maybe I could have looked at it this way. Could I have looked at this triangle here? Well, I guess that's not look at that triangle right away. Let's look at this one. Let's look at that triangle. Do you know two angles of that triangle? So you know automatically the third one? Okay, so 90 plus 25 is 115, right? Well, 180 minus 115 gives me 65 degrees for that angle right there. Now, what's the relationship then between that 65 and that angle right there? 65, like vertical, right? So 65. Okay, so maybe I start transitioning values so that I can start filling in things that I didn't know at the onset of the problem. Okay, so that's 65. I don't know if I can go any further to find y or x in that situation. So maybe I start looking at, so that was 65, that was 65. What if I do look at that triangle? Is there anything in that triangle that we can figure out? I don't think there really is. I mean, I can find out, if that's 65, that's got to be 115 and 115, right? But in that blue triangle, maybe there's nothing there. So it's kind of nice to be, as proving a point to you, as you're finding values, sometimes they don't lead you anywhere, right? And you just got to kind of look at it from a different approach. What if I look at that triangle right there? Do you know two angles in that triangle? You know the 65 and the 25, right? What's that add up to? 90, right? Does that tell you then that that angle there has to be 92? Or 90 as well? Okay. So if that's 90, what's x got to be? X is got to be 90 as well. Okay. So I found x to be 90. Let's see if x is 90. Now I can maybe, with knowing that this is 65 and this being 90, is that an alternative way? If I look at that little triangle there that we tried to look at earlier, we couldn't find y, but now that I have two angles in it, can I find y to be 25 again? So the whole purpose, the whole reason of going over that problem is you're going to run into roadblocks at some point. Okay? Don't erase anything that you have found to be true. Just start the problem again, looking at it from different angles, different viewpoints, and that might allow you to make a conclusion eventually. That's the kind of thing I think is sometimes problematic